When using galvanized 90-degree elbows with polyvinyl chloride or PVC pipe, bonding is necessary to prevent galvanic corrosion. This occurs because the dissimilar metals, galvanized steel and PVC, can react electrochemically in the presence of moisture, leading to premature failure of the connection. Two primary methods exist for bonding galvanized 90 degrees to PVC pipe: mechanical bonding and electrical bonding. Firstly, let's discuss mechanical bonding. This approach involves physically connecting the metal and plastic components. Use a stainless steel spring clamp or a bonding strap to achieve this. Ensure that the clamp or strap makes good electrical contact with both the galvanized surface and the PVC pipe surface. The clamp should be adequately sized. For instance, for the 80-foot pull mentioned, use a stainless steel spring clamp with a diameter of at least 2.5 inches. If using a bonding strap, select one that is at least 1 inch wide and made of stainless steel or copper. The key is to ensure the bond is secure and provides good electrical contact. Secondly, consider electrical bonding. This method involves creating an electrical pathway between the galvanized 90-degree elbow and the PVC pipe, even though PVC itself is a non-conductor. Attach a bonding wire, typically 8 to 12 gauge stranded copper, to the galvanized 90-degree and connect it to a metallic grounding point that is electrically continuous with the PVC pipe's electrical system. Use a split bolt, ground clamp, or wire nut to create the electrical connection. Ensure the connections are tight and corrosion resistant. Also, consider these additional tips. Firstly, utilize a dielectric union. A dielectric union is a specialized fitting incorporating a plastic insert. This insert electrically isolates the metal and plastic components, thereby preventing galvanic corrosion. It is installed between the galvanized 90-degree elbow and the PVC pipe. Secondly, apply anti-seize compound. Applying anti-seize compound to the threads and contact surfaces of the connection can help prevent corrosion between the metal and plastic. This compound creates a barrier against moisture and reduces friction. Thirdly, avoid over-tightening. Over-tightening the connection can damage the PVC pipe, potentially compromising the bond and leading to leaks or structural failure. Tighten the fittings to the manufacturer's specified torque. Fourthly, test the bond regularly. Use a multimeter to verify the integrity of the electrical connection. Measure the resistance between the galvanized 90-degree elbow and the grounding point. A low resistance reading, ideally close to 0 ohms, indicates a good bond. Check the bond periodically, especially in damp or corrosive environment. Regarding the 80-foot pull length, it is crucial to ensure that the bonding is particularly robust. The longer the run, the greater the potential for electrical imbalances and corrosion. Therefore, selecting appropriate bonding hardware and ensuring secure connections are essential for a reliable and long-lasting installation. If the PVC pipe contains any metallic components or is connected to metallic systems, proper grounding and bonding become even more critical. This ensures electrical safety and prevents fault currents from energizing the piping system. Remember to consult local electrical codes and regulations for specific requirements regarding grounding and bonding of metallic and non-metallic piping systems. These codes provide detailed guidelines on acceptable methods, materials, and sizing of bonding conductors. Proper bonding is not just a matter of preventing corrosion. It is also a crucial safety measure that helps to minimize the risk of electrical shock and equipment damage. Always prioritize safety and adhere to established standards when working with electrical systems. When selecting bonding hardware, choose components that are specifically designed for grounding and bonding applications. These components are typically made from corrosion-resistant materials such as stainless steel or copper and are designed to provide a secure and reliable electrical connection. Ensure that the bonding conductors are properly sized to handle the potential fault current. The size of the bonding conductor is determined by the size of the circuit conductors and the applicable electrical codes. When making electrical connections, use approved methods and materials. For example, use compression connectors or split bolt connectors to create secure and reliable connections between the bonding conductors and the equipment grounding conductors. Avoid using wire nuts for grounding connections, as they may not provide a reliable electrical connection under fault conditions. When installing bonding jumpers, ensure that they are as short and straight as possible. This minimizes the impedance of the bonding jumper and ensures that it can effectively carry fault current. Avoid creating loops or kinks in the bonding jumper, as this can increase its impedance and reduce its effectiveness. When bonding dissimilar metals, such as galvanized steel and copper, use a listed and labeled connector that is specifically designed for use with dissimilar metals. This helps to prevent galvanic corrosion and ensures a reliable electrical connection. Inspect the bonding connections periodically to ensure that they are still tight and corrosion-free. If you find any loose or corroded connections, tighten or replace them as needed. Keep a record of all grounding and bonding connections, including the location, size, and type of conductor, and the date of installation. This information can be helpful for troubleshooting and maintenance purposes. When working on electrical systems, always de-energize the circuit before making any connections. This helps to prevent electrical shock and ensures your safety. Use a voltage tester to verify that the circuit is de-energized before beginning work. Wear appropriate personal protective equipment, such as safety glasses, gloves, and a hard hat. This helps to protect you from electrical shock, burns, and other injuries. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to have the necessary training and experience to do the work safely. By following these guidelines, you can ensure that your electrical systems are properly grounded and bonded, which helps to prevent electrical shock, equipment damage, and fire. Proper grounding and bonding is an essential part of electrical safety, and it is important to take it seriously. Regularly check the physical condition of the installed bonding clamps, straps, and wires. Look for signs of corrosion, damage, or loosening. Replace any components that show signs of wear or degradation to maintain the integrity of the bonding system. Periodically test the resistance of the bonding connections using a multimeter. Measure the resistance between the bonded components to ensure it remains low, ideally close to 0 ohms. A significant increase in resistance indicates a potential problem with the connection, such as corrosion or loosening. Address any issues promptly to maintain effective bonding. Ensure that all bonding conductors are properly supported and protected from physical damage. Avoid running bonding conductors in areas where they could be easily damaged by impact, abrasion, or exposure to corrosive substances. Use appropriate supports and enclosures to protect the conductors and maintain their integrity. Keep bonding connections clean and free from dirt, debris, and contaminants. Clean the connections regularly to remove any buildup that could impede electrical conductivity. Use a wire brush or other suitable cleaning tool to remove corrosion or oxidation from the connection surfaces. Avoid using harsh chemicals or abrasive cleaners that could damage the bonding components. When adding new electrical equipment or making modifications to existing systems, ensure that the bonding system is properly extended and updated to accommodate the changes. Add additional bonding conductors and connections as needed to maintain effective bonding throughout the system. Verify that all new equipment is properly bonded to the grounding system. In corrosive environments, such as those found in coastal areas or industrial facilities, take extra precautions to protect bonding connections from corrosion. Use corrosion-resistant materials for bonding hardware and conductors. Apply protective coatings or sealants to the connections to prevent moisture and contaminants from penetrating. Inspect bonding connections more frequently in corrosive environments to detect and address any signs of corrosion early on. If the PVC pipe is buried underground, ensure that the bonding connections are protected from soil moisture and corrosion. Use direct burial rated bonding connectors and conductors. Wrap the connections with waterproof tape or sealant to prevent moisture from penetrating. Consider using cathodic protection to mitigate corrosion of buried metallic components. Proper documentation of the bonding system is essential for maintenance and troubleshooting. Keep records of all bonding connections, including the location, size, and type of conductors, and the date of installation. Update the documentation whenever changes are made to the bonding system. Use the documentation to track the performance of the bonding system over time and identify any potential problems. Regularly train personnel on the importance of proper bonding and grounding practices. Educate them on the potential hazards of improper bonding and the correct procedures for inspecting, maintaining, and repairing bonding connections. Emphasize the importance of following established standards and guidelines for bonding and grounding. Promote a culture of safety and awareness regarding electrical bonding and grounding. Encourage personnel to report any concerns or potential problems with the bonding system. Foster open communication and collaboration to ensure that bonding issues are addressed promptly and effectively. The information provided is intended to offer general guidance on bonding galvanized 90-degree elbows to PVC pipe. Always consult with a qualified electrician or electrical engineer for specific recommendations and to ensure compliance with local electrical codes and regulations. Electrical work can be dangerous, and it is important to have the necessary training and experience to do the work safely. If you are not comfortable working on electrical systems, hire a qualified professional to do the work. Always prioritize safety and follow established standards when working with electrical systems. With the right knowledge and precautions, you can ensure that your electrical systems are properly bonded and grounded, which helps to prevent electrical shock, equipment damage, and fire. Remember that electrical codes and standards can vary depending on your location. It is important to consult the latest edition of the National Electrical Code or other applicable codes to ensure that your bonding and grounding practices comply with local requirements. In some cases, local codes may have more stringent requirements than the national codes, so it is essential to be aware of these differences. In addition to the National Electrical Code, there are other industry standards and best practices that can provide valuable guidance on bonding and grounding. These include standards from organizations such as the Institute of Electrical and Electronics Engineers and the National Fire Protection Association. Consider attending training courses and workshops on bonding and grounding to stay up to date on the latest technologies and best practices. These courses can provide valuable insights into the design, installation, and maintenance of bonding and grounding systems. Networking with other professionals in the electrical industry can also be a valuable source of information and support. Share your experiences and learn from others to improve your knowledge and skills in the field of bonding and grounding. Regularly review and update your bonding and grounding practices to ensure that they are consistent with current standards and best practices. As technology evolves and new materials are introduced, it is important to adapt your practices accordingly to maintain the effectiveness of your bonding and grounding systems. Consider using specialized software tools to assist with the design and analysis of bonding and grounding systems. These tools can help you to model the performance of your systems and identify potential problems before they occur. They can also help you to optimize the design of your systems to minimize costs and improve performance. Remember that proper bonding and grounding is an ongoing process that requires continuous attention and maintenance. By taking a proactive approach to bonding and grounding, you can help to ensure the safety and reliability of your electrical systems for many years to come.